Dear students, in continuation with the series of numericals which is based on the electrostatic, we are having a question. Three charges of equal magnitude Q are placed at the vertices of an equilateral triangle of side A. The force on a charge Q placed at the center of a triangle is given by. Options are also given. Means we are solving the questions, we are solving the numericals, and simultaneously we are having the MCQs. So both purpose will be solved, and it will be helpful for you to solve the for competitive examination. So here if we go through this is a triangle which is an equilateral triangle and it is the center. Now these three charges which is placed at vertices, and they are another charge which is Q which is placed here. Now this charge which is acting at the center, so force because of this, there will be a force because of this charge, because of this charge, and because of this charge, and it is at the center. So first of all we have to calculate the distance from here and here to know the force. Now if we go through this, if we take this triangle, I am putting them here, it is AD. So AD is perpendicular and this AB is hypotenuse. So AD upon AB will give the angle. This angle is of 60 degree because equilateral triangle all are having a angle of 60 degree. So it is sine 60. Now AD is equal to AB sine 60, and sine 60 is having value which is equal to root 3 by 2. So it is A into root 3 by 2. This will give the AD. Now we want to know this OA, OC and OB. So here we can have OA which is equal to OB because it at the center. OB is equal to OC which is equal to 1/3 of the AD. Sorry, 2/3 of the AD. 1/3 will be this distance. Now 2/3 will be of this. So 2/3 and AD is this A root 3 upon 2. So this will give the value which is A upon root 3. So we have got the distance OA which is equal to OB which is equal to OC. This is the distance which we have got, this and this. Okay. Now once we have got this distance, now we can calculate the force. Now see how the force is acting. Here if we take the force because of A which is acting like this at the center O. So we can call it as force O on because of A. Now this force is a repulsive one, so it is acting in this direction. If we go through the B, it is also acting in this direction, so we can take this force, that is F OB because of this. And similarly here, if we go this, it is also a repulsive force which is acting in this direction, FOC. If you draw here, you can draw here it also. So here three forces which is acting at the center. The nature of these forces are repulsive. Now if you see, this force is acting in this direction and this is angle of 120 degree. This angle is of 120 degree, and if we draw a parallelogram, what we are getting according to law of parallelogram of force which will be acting in this direction opposite to this, we can name it as F. Now this force and this force which we have to calculate. So first of all we will see the FOA. Now what is the value of FOA? Both all the charges are of equal magnitude and this charge is of Q. So we will be having the force which is FOB which is equal to FOC. All the forces will be equal in magnitude and direction which we have seen. So we are going to calculate 1 upon 4 pi epsilon naught into Q upon Q into this Q, and the R square, that is your, that is how much? A root 3. So we are substituting it here, A root 3 square. So finally we are having this FOA which is equal to FOB which is equal to FOC. I am writing only it. So it is 3 root 3 square, that is 3 4 pi epsilon naught Q into Q upon A square. Now finally what we have got? We have got the forces which is acting. Now if we go through this force which is acting, that is FOA is of this magnitude, FOB is of having same magnitude, and FOC is having same magnitude. Now we apply the law of parallelogram to know the magnitude of this force. So F will be given by FOB square plus FOC square plus 2 times FOB into FOC into cos 120. This angle is of 120 degree, because this angle is 120 degree, this angle is also 120 degree, this angle is also 120 degree, because it is acting at the center, and you will see the point. This angle is of 120, this angle of 120, and this angle of is of 120 degree. Now here, if we go through this, we know that FOA is equal to FOB is equal to FOC, and we got the magnitude. So first we will calculate it simply. So this is 2 times FO square, we can call it as, plus it is also 2F FO square, and cos 120 is minus 1 by 2. So this 2 will be cancelled, and finally we are having the 2FO square minus FOA square. So it is FOA square under root. Here what we have got, the magnitude of the force which we have got FO, which is acting in this direction. F is equal to, either we can say the magnitude of this force and the magnitude of this force is equal, but both are acting in the opposite direction. So here FOA means we have got this value 3 upon 4 pi epsilon naught into Q upon A square. Now if you see the force which is acting in the direction opposite to the direction of force, so here we can have the resultant force will be equal to 0. F minus FOA, which is equal to 0, because F is equal to FOA. So this force which we have got F, and we have calculated F, which is equal to FOA, and FOA is having this value. And similarly FOA is also, all the forces which is acting, they are having the same magnitude, but it is acting, the resultant is also the same which we have got. This is resultant which we have got, that is F. So finally we can say F minus FO, both the forces acting opposite to each other, equal in magnitude. So resultant is going to be 0. So the correct answer is 0. So by using the Coulombs law, how we have to apply the Coulombs law, and using the law of parallelogram, we have got the answer. So this way we can go with such questions which may ask to you in the competitive examination.